Alright, let's prepare this solution. Now it's time to talk about stoichiometry. Okay, so I know this is complicated, but it is not so complicated if we are able to memorize certain formulas. The first formula that we have to memorize, it is that basically molar mass is equal to mass over moles. And also that the molarity, which is a concentration unit, it's equal to the number of moles divided by the amount of liters, which is volume of solution. Now, we have to read the problem before to start to solving, because it is necessary to isolate the variables that we know and the variables that we don't know. So, what are the variables that we know? If we pay attention to the problem, it says then calculate the required mass of sodium hydroxide to prepare a 500 milliliter solution of 2 molar of sodium hydroxide. So, following this problem, we know these two things. That we require a volume of 500 milliliters. And remember, we work with liters because that's molarity unit. So we have to turn those 500 milliliters into liters. So remember that 1000 milliliters, it's basically 1 liter. What I did here, in stoichiometry and in dimensional analysis, we have kind of like a rule. So the unit that we have, we're going to set it in the denominator. And the unit that we want, we're going to set it on the numerator. Now we have to find a relationship between the unit that we have with the unit that we look. So we know that 1000 milliliters is equivalent of 1 liter. Therefore, we can write 1000 milliliters equals to 1 liter. Please pay attention to this because it's a common mistake and it's to write the 1000 in the wrong spot. So milliliters, it is lower than liters. Remember that the prefix milli, which stands with an M lowercase, it stands for 1000th part. So it is always lower. Millimeter, it is lower than a meter. Milligram, it is lower than a gram. Specifically, 1000th part of that unit. In the same case, milliliters, it is the 1000th part of a liter. So there's a mnemonic, and always the 1000 will go to the unit that is smaller, okay? Now, we cancel each other, we cross out the milliliters with the milliliters, and then we have 5.5 liters. That's our volume. Now, what other variable do we know? Concentration. So the concentration, we write it with the letter C. That will be like the symbol that we are used for concentration. But remember that concentration can have several types. We can have molarity, we can have molality, we can have percentual composition that could be like mass over mass, volume over volume, or mass over volume, okay? In this case, the type of concentration that we have, it is molar. So the concentration, it is how much? 2 molar. We have 2 molar of sodium hydroxide. Pay attention with this because this could be a bit complicated. When M is on the other side of the inequality, it's a variable. But when M, it is followed by a number, it's a unit. Both of them are the same. Uppercase M, it is molarity, which is moles per liter, but also M followed by a number is a unit. In this case, indicates molar. So we have 2 molar of sodium hydroxide. All right, so we need to find the amount of mass required for making this. So we know the concentration and we know the volume. So what can I use to solve this? If we pay attention right here, the formula molarity relates the concentration with the volume, molarity with liters. And we require to find the mass. But we are not able to find concentration directly to mass. But what we can do, it is using concentration to find the number of moles, and with the number of moles using the molar mass, we will be able to find the mass required for that. So it's a little bit, we have to turn sometimes, but that is the easiest way. So we have the concentration. Okay, so we have to solve this inequality. So we have molarity is equals to moles per liter. So rule of thirds, we just clear moles, and the equation that we got, it is this. We got that moles is equal to molarity times liter. Okay? And we already know what is the molarity. The molarity is 2 molar. And we know the amount of liters, which is 0.5. Now, what is the product of this? Well, easily we know that it's 1, but that's my question. My question is this: what is the unit of this? Yes, I know we're finding moles, therefore we will find moles. But how can I clear that molarity times liter, it is equals to moles? Remember, the molarity is moles per liter. So I can change my molarity unit, which is molar, per the equivalent. In this case, it is moles per liter. And now it is clear, then we can cross out liters, and the result will be moles. And moles of what, by the way? You cannot write me just moles and that's it. You have to write me moles of sodium hydroxide, because that's what we got. All right? So this is the number of moles. A couple of things that I have to explain. So molarity, or concentration, it is expressed in molar, molality, and molality, percentual composition. But when we are talking about moles, we have like a unit, please don't forget it, it is N. When we write N, we are talking about moles. So N is equals to 1 mole of sodium hydroxide. Now I need to find the mass. So we use this equation. Look at this. We can solve this problem only with these 2 equations. So we have moles, I'm sorry. And we always know the molar mass, because the molar mass, it is nothing more than the addition of the atomic weights of every single element in a molecule. So for instance, sodium, it weighs 23 grams per mole. By the way, always use the units grams per mole, even when the periodic table does not give you any kind of unit, because the periodic table do not use units. Usually it's unitless. Sometimes use another type of unit that is called UMA, and that is unit of atomic mass, UNM. So it's not very useful. Try to use grams per mole, okay? So sodium, it weighs, following the periodic table, look in your periodic table, and you will find in sodium it is 23 grams per mole. Then we have oxygen. Oxygen, it is 16 grams per mole. And hydrogen, it is 1 gram per mole. When we just do the math of this, that would be 40 grams per mole. And this is the molar mass for sodium hydroxide. Now, I know the molar mass, I know the number of moles. Let's clear mass. So mass would be then, let's clear mass, that would be molar mass times moles. All right? And molar mass, we already found that it is 40 grams per mole. And the number of moles, we found it already. So it is 1 gram. I'm sorry, 1 mole. 1 mole of sodium hydroxide. So we solve this. This is a very simple mathematical equation that gave us 40 grams. And that's it. For preparing 500 solution of a 2 molar sodium hydroxide, we require only 40 grams. And what is the translation of this? I mean, I know that we are solving a problem, but what is the equivalent in reality? It means that if you go to the lab and I told you, hey, I need that you prepare a 500 milliliter solution of 2 molar of sodium hydroxide, what do you need to do? You will take 40 grams of sodium hydroxide, and you will add those 40 grams of sodium hydroxide right here to the round bottom flask, and then you will add 1 liter of solution. 1 liter of solution, no, 500 milliliters. But that's a lie. Actually, when we prepare a solution, what we add, it is kind of like 200 milliliters. We add 200 milliliters, we just mixture the solution until the solid is completely dissolved, and then we complete until there is a line in every single instrument. It tells you how much it is 500 milliliters. So you don't add 500 milliliters because the density of the solid, it is different, so the volume can change. So we cannot add 500 milliliters because the concentration won't be exactly 2 molar, would be lower or bigger. So to avoid that, we just add slowly the amount of water until we reach the line that says that in the solution now we have 500 milliliters. And then, you will have prepared the 2 molar sodium hydroxide solution of 0.5 liters. And that's it. Now we can do it on lab.